You know that old saying, right? Measure twice, cut once.
Oh, sure. It's basically the carpenter's golden rule, printed on every tape measure in the world.
Right. But now I want you to imagine you aren't just building a birdhouse or a backyard deck. You're building a multi-billion-dollar offshore processing plant or, a high-speed rail network through a mountain range. Measured twice doesn't exactly cut it anymore, does it?
No, absolutely not. At that scale, if you wait until you're actually cutting to realize you measured something wrong,
Yeah.
you've already lost millions, maybe hundreds of millions.
Yeah.
And honestly, it's not even just about the money at that point. It's about safety, reputation, and just years of people's lives invested in a massive project.
Exactly. And there is this very specific nightmare scenario in engineering that keeps project directors up at night. And I'm not talking about the building collapsing or pipes bursting. Those are disasters, sure. But I'm talking about, well, the perfectly executed failure.
Ah, yes. The tragedy of competence.
Right. The scenario where you spend 5 years building something. You pour the concrete, wire up all the electronics, finish it perfectly according to the blueprints. You turn the key, and it doesn't solve the problem it was supposed to solve.
Or it solves a problem nobody actually had.
Exactly.
That is the classic textbook distinction between doing things right and doing the right thing.
And believe it or not, avoiding that very specific nightmare is the entire reason the source material we're looking at today even exists.
And that's what we are unpacking in today's deep dive. We're going through a document labeled E3.6. It's technically titled The Employer Requirement for Verification and Validation. And look, I know those words. Verification, validation.
They sound a bit dry.
Yeah, they sound like the worst kind of corporate checklist jargon, like
Yeah.
something you'd completely sleep through during HR orientation.
They really do have that reputation. It sounds like paperwork just for the sake of paperwork.
But after actually reading through this, it feels way less like a checklist and more like a defense mechanism. It's essentially a survival guide for mega projects. That's a really great way to frame it. This document isn't about the engineering itself. It's not telling you how thick the steel needs to be or what specific grade of cement to use. It's a governance model.
Right.
It's the strict system that ensures that what you think you're building is what you actually build. And even more importantly, that what you build is what the client actually needs.
So let's get right into the machinery of this. Document E3.6, it lays out a very specific methodology called the V model. But before we visualize that, and it is a very visual concept, we really have to deal with the vocabulary. Because I'll be completely honest, in normal everyday life, I use the words verify and validate interchangeably.
Most people do, yeah.
Right, like if I verify my parking ticket, I'm validating that I parked there. It's the exact same thing in my head.
In conversational English, absolutely. You swap them and nobody blinks an eye.
Yeah.
But in systems engineering, and specifically in the context of this document, conflating those two words is genuinely dangerous. Section 1 of E3.6 draws a very hard line between them.
A hard line.
Yeah, if you mix them up on a billion-dollar project, you are going to have a very bad time.
Okay, so let's define them properly for everyone listening. What is the official split?
Let's start with verification. The document defines this as the evaluation of whether a product, a service, or a system complies with a regulation, a requirement, or a specification.
So verification is basically asking, did we follow the instructions?
Precisely. It's an objective check. If the blueprint says to install a grade 5 bolt at this exact coordinate, and you install a grade 5 bolt at that coordinate, you have verified that task. It is a binary state. Pass or fail against the spec. So the fundamental question is, did we build it right?
Okay, that makes perfect sense. It's the compliance check, which brings us to validation.
Right. Validation is the assurance that the product actually meets the needs of the employer and the stakeholders. So the question here completely changes. It becomes, did we build the right thing?
I really love that distinction. Did we build it right versus did we build the right thing?
Think of it this way. You could build a car. You verify the engine works. The wheels are perfectly round. The brakes stop the car within the required distance. It is 100% verified against the design drawings.
Right.
But if the customer actually needed a boat to cross a river, that car is totally useless. You verified the product perfectly, but you failed validation.
And that's the perfectly executed failure we were just talking about. You followed every single rule, but you missed the point entirely.
And document E3.6 is designed specifically to force the contractor to do both.
Meh.
You can't just be a robot blindly following a blueprint. You have to ensure the blueprint is actually solving the operational problem. You verify the bolt, but you validate the machine.
Keep these two things in check, and to keep them synchronized, the document uses this V model concept. If you're listening to this right now, I want you to try and visualize a massive letter V. We start at the top left, we go down to the bottom point, and then we climb back up the right side.
This represents the entire life cycle of the project. And the shape really matters here. It's not a straight line from start to finish. It's a descent into extreme detail, followed by an ascent back into reality.
Let's walk down that left side first. The document calls this the project definition and design phase.
Right. So think of the left side as a descent from the abstract into the concrete. You start at the very top left with user requirements. This is the dream phase. Like, I want a factory that produces 500 widgets a minute. Or I want a train that gets me from London to Paris in 2 hours.
It's high level. It's just what the client wants the world to look like when the dust settles.
Exactly. Then you take a step down the V. You get to basic design. Now you're sketching out roughly how that factory might look to achieve that production rate. Then you take another step down to feed requirements. That stands for front-end engineering design. We're getting much more technical now.
And finally, you hit the very bottom of the left slope, which is detailed design.
This is the nuts and bolts. Literally. At this stage, you aren't talking about making widgets anymore. You're talking about the exact torque settings on a specific valve or the wiring diagram for one specific control panel. You have decomposed the big dream into millions of tiny executable instructions.
So that's the left side. Decomposing the problem, taking the big idea and smashing it into tiny pieces. And now we hit that pivot point at the very bottom of the V.
A build phase. Procurement and construction. This is actually the only time physical reality exists in the model. You take that detailed design and you turn it into real steel, concrete, and wire.
But you don't stop there. And this is where I think the model gets really fascinating. You don't just build it, dust off your hands, and walk away. You have to climb back up the right side of the V.
The project integration and testing side. And here is the real beauty of the geometry. Every single step up on the right side mirrors a step on the left side.
I noticed that exact symmetry when I was looking at the source diagram. So immediately after construction, the very first step up on the right is integration and testing. And that sits directly across from detailed design on the left.
Right, because you are testing the specific parts you just designed. Does the valve open?
Yeah.
Does the motor spin? You are verifying the detailed design. You aren't checking if the whole factory works yet. You're just checking if the individual parts work.
Then you go up a level to systems and subsystems.
Which perfectly mirrors the feed requirements on the left. Now, you aren't just checking if the valve opens. You're checking if the cooling system as a whole actually cools. You're checking how the components interact as a group.
Then you move up to operation and maintenance, which mirrors the basic design. And finally, at the very top right, you have project performance,
which directly answers the user requirements from the top left. It closes the entire loop. The user originally asked for 500 widgets a minute. The project performance test measures if we actually got 500 widgets a minute.
And there are these arrows in the diagram cutting horizontally straight across the V. They connect the left stages directly to the right stages.
Those arrows are arguably the most critical part of the diagram. They represent the verification and validation feedback loop. When you are on the right side, testing a system, you aren't just guessing what the pass or fail criteria should be. You look straight across the V to the design phase on the left and ask, does it match that?
So the V model isn't just a project timeline. It's a mirror. The right side is constantly answering to the left side.
Exactly. It forces you to prove that every level of complexity, from the single bolt all the way up to the entire factory, matches what was intended at that specific level. It totally prevents you from getting to the end and realizing, oops, we built the wrong thing, because you've been checking it at every single level of the ascent.
Yeah. Now, a philosophy is nice and pretty diagrams are great, but this is a strict contract document. It's not asking for a general vibe, it's demanding a concrete plan. Section 2 of the document calls for the Verification and Validation Plan, or VVP. And looking at the timeline they mandate, it is incredibly aggressive.
They really are. The contractor has exactly 30 days from the commencement date to submit this plan.
30 days. For a mega project, that feels like an absolute sprint. You're barely setting up your site trailers, you probably haven't even hired your full engineering team yet, and the client wants a comprehensive quality roadmap.
It's a deliberate stress test. It forces discipline immediately. If you start a billion-dollar project and you don't even know how you're going to verify your work in the first month, you're already in deep trouble. This ensures that quality isn't something you just bolt on at the end when you run out of time. It's baked into the foundation.
And reading the requirements for this VVP, it's clearly not just a one-pager saying, we promise to do a good job. It asks for the who, the how, and the when.
It demands a very detailed breakdown of roles. It asks for focal points per discipline. You can't just have one generic quality manager running around the site with a clipboard. You need a structural expert verifying the structure, an electrical expert verifying the electrical, a process expert verifying the flows. It forces the contractor to resource the project correctly from day one.
It also specifically asks for the tools. Quote, description of requirements management system to be used.
Yeah, that part is key. You can't manage 50,000 requirements on an Excel spreadsheet. Well, you can try, but you'll fail miserably. This clause forces the contractor to admit exactly what software database they are using to track this massive complexity. It signals to the employer, we have the technology and the infrastructure to actually handle this.
What I found fascinating is that the document lists a whole ecosystem of other massive documents this VVP has to align with. It's not a standalone thing at all. It lists the engineering plan, the quality management system, the risk management plan.
That's a crucial insight. V&V is the thread that ties all of those together. Think about it. If your risk management plan says, we have a high risk of saltwater corrosion, so we need a special coating on the pipes, that's just a statement. It's just words on paper. The V&V plan is what turns that into a strict test procedure to physically check the coating thickness.
Right, so without the V&V plan, the risk plan is basically just a wish list.
Exactly. If those plans don't talk to each other, you have a massive gap in your armor. You might have identified the risk, but you have no actual way of verifying that you mitigated it.
So verification and validation effectively becomes the central nervous system of the project. It touches absolutely everything, from how you buy materials to how you inspect the final build.
And the brain of that nervous system is what Section 3 calls the requirements register.
This part, look, if you love data, Section 3 is your happy place. If you hate administration, this sounds downright terrifying. The document says the contractor must maintain a requirement breakdown structure, or RBS.
Just like you have a work breakdown structure to manage the physical construction, you need a requirement breakdown structure to manage the rules. You can't just have a giant, messy bucket of to-dos. You need to categorize them.
The source lists the minimum categories: performance, functional, design, procurement, construction, commissioning, even administrative requirements.
Everything is a requirement. And this is exactly where people get tripped up. If the contract says the contractor must submit a progress report every Tuesday by 5 p.m., that is an administrative requirement. It goes in the register, it gets a specific line item, it gets verified.
That is a level of granularity I just didn't expect. I assumed this was just for things like, is the steel strong enough? But they want to verify that you actually sent the email on time.
Because on these massive projects, administrative failure almost always leads to technical failure. If the reports aren't verified, communication breaks down. If communication breaks down, you build the wrong thing.
And when we look at the actual register, the rows and columns of this database, document E3.6 is incredibly specific about what data points need to be there.
It has to be. This register is the single source of truth for the whole project. Section 3 outlines the mandatory columns. First, you need a requirement ID. Every single requirement needs a totally unique ID number.
Which makes sense. You can't just say, fix the pipe issue if there are 500 pipes on site. You need to say, requirement ID 104B.
Exactly. Traceability is key. Then you need the source document. Where did this requirement even come from? Was it a government regulation, a client email, a specific page in the design code? You have to link it back to the origin.
Why is that source column so important?
To avoid scope creep. If a requirement somehow appears in the register, but you can't point to the source document that demanded it, why are we doing it? Why are we spending client money on it? It keeps the whole project honest.
I see. And then we get to the proof. This is the part that really stood out to me. There is a column for verification action, meaning what is the plan to prove this, and then a column for verification report.
That verification report column is where the rubber meets the road. You cannot just mark a requirement as closed or done based on trust. You have to provide a hyperlink to actual documentary evidence, a test report, a photo log, a signed certificate, a laboratory result.
So the register essentially becomes a massive library of evidence.
Correct. If I am the employer and I want to know if the fire alarm system meets the spec, I don't call you up and ask, hey, is it done? I go to the register, I find the unique requirement ID for fire alarms, I scroll over to the verification report column, I click the link, and I look at the test results myself.
It totally removes trust from the equation and replaces it with proof.
Which is really the only way to manage a project where lives and billions of dollars are at stake. You trust your mother. You verify your contractor.
But this isn't a static document, right? You don't just fill it out at the end of the job like taking a final exam.
No, Section 3 is very explicit about this. It must be updated periodically and specifically linked to the project progress meetings. It's a living organism. It changes status from open to in progress to closed as the project moves forward. If you aren't touching the register every single week, you aren't managing the project.
Which brings us perfectly to the governance side of things. How do we keep this beast alive? Section 4 and 5 talk all about reporting and meetings.
This establishes the rhythm of the project. Section 4 mandates that the contractor issues an updated requirements register on a monthly basis, right alongside the progress report. Every month, you have to show your scorecard. You show what you closed, what's still open, and where you're stuck.
And you can't hide. Section 5 talks about specific verification and validation meetings. These aren't just general catch-ups where everyone drinks coffee and nods at each other.
No, the sole focus of these meetings is requirements management. And there's a very specific rule about the engineer, the person representing the employer. The document states that the engineer must be invited 14 days in advance.
Why 14 days? That seems incredibly specific and honestly kind of long. Why not just 48 hours?
It completely prevents the ambush meeting. It prevents the contractor from saying, hey, we're having a meeting tomorrow morning to sign off on these complex systems. Hope you can make it.
I see. Trying to slip things past the goalkeeper.
Exactly. The 14-day rule ensures the engineer has 2 full weeks to review the register, check the evidence, read the test reports, and come to the table armed with difficult questions. It enforces transparency by giving the other side time to actually prepare. It levels the playing field.
And it says the contractor is responsible for the minutes, so if something is agreed upon, it's written down immediately.
Documentation is the only reality in contract law. If it isn't in the minutes, it didn't happen.
But the biggest governance hammer in this entire document, the thing that really gives it teeth, is the last paragraph of Section 5. You called this a hard gate.
I did. The text explicitly says, the contractor shall perform and document a full verification and validation assessment for each project phase to be finalized before the start of the next phase.
Before the start of the next phase. That's a massive stop sign.
It is a massive stop sign.
Yeah.
Think about the intense pressure on a construction site. You finish the design phase, everyone is excited, the investors want to see physical progress, the concrete trucks are literally idling in the parking lot, burning fuel, the foremen are yelling to get started.
It's pure momentum.
Right. But this clause says, wait, stop everything. Have you finalized the V&V assessment for the design phase? Have we definitively proved the design works? If the answer is no, the trucks do not move.
You literally cannot proceed to construction if you haven't verified the design.
It protects the project from its own momentum. The single most expensive mistake in engineering is finding a design flaw after you've already poured the concrete. It costs 100 times more to fix it then. It involves jackhammers and lawyers. This hard gate forces you to stop, check the work, and only then proceed.
It essentially invalidates the "we'll just fix it later" mentality.
We'll fix it later is the absolute death knell of mega projects. Document E3.6 makes fixing it later a literal breach of contract.
It's incredible. You look at a document like E3.6, and at first glance, it's just dry text. It looks like boring administration. But when you really see how it works, the V model, the 30-day plan, the register with the unique IDs, the hard gates, it's actually this incredibly sophisticated machine.
It really is. It's a machine entirely designed to convert ambiguity into certainty. We start with user requirements, which are often just vague hopes and dreams, and we grind them through this V model until they come out as project performance. Proven, tested reality.
So if we zoom out for a second, why does this matter to the listener? Why should the average person care about document E3.6?
Because we live in a world of increasing complexity. Whether it's software, public infrastructure, or medical devices, good intentions just aren't enough anymore. You need a rigorous system. This document is basically a masterclass in how to operationalize quality. It transforms "I hope it works" into "I can prove it works."
And it reminds us that verify and validate aren't just synonyms. They are the two halves of the whole truth.
Exactly. You need both. You need to follow the rules, and you need to make sure the rules still make sense.
Before we wrap up, I want to leave you with something to chew on. We've spent this whole deep dive talking about the sheer rigor of this process. The breakdown structures, the ID numbers, the linked reports, the 14-day notice. It's very well mechanical.
It has to be to function at that scale. You can't run a billion-dollar project on vibes.
True. But here is the provocative thought. We spend so much energy on the verification part. filling out the register, checking the boxes, linking the reports. It's satisfying. It's measurable. You can make a nice pie chart out of it. But does that sometimes distract us from the validation part?
That is the inherent danger of bureaucracy. You can get so obsessed with the perfect paperwork verifying every single screw and bolt that you completely lose sight of the user standing at the top of the V. You can have a project that is 100% verified, all green lights in the register, every test passed. But if the world changed while you were building it, or if you just stopped listening to the user halfway through, you validated absolutely nothing.
So you end up right back at the perfectly verified failure we started with.
Exactly. The document demands both. But balancing the bureaucratic safety of verification with the human empathy of validation, that is the real art of engineering. That's the hard part.
And that is exactly why, despite all these databases and V models, you still need actual humans running the show.
And humans who know the fundamental difference between building it right and building the right thing.
That's a wrap for this deep dive into document E3.6. Next time you walk into a skyscraper or ride a train, just think about the millions of rows in a database somewhere that simply said, verified. Thanks for listening.
Stay curious.
If you're interested in the templates, please visit our shop. The link is in the description.
Thanks for watching. Please subscribe and see next time.